Ever wondered how your data stays private when apps learn from millions of users? Or why some AI systems can guess personal details even when they're not supposed to? Today, we're diving into a groundbreaking study that reveals a critical vulnerability in AI privacy. Specifically, how bad actors could identify who owns a data point in a federated learning system. Let's start with the basics. Federated learning, FL, is a technique where AI models learn from decentralized data without ever seeing it directly. Think of it like a group project. Each participant works on their own dataset, and only the final model updates are shared. This keeps sensitive information, like medical records or social media activity, private. But here's the catch. Even in this secure setup, researchers have uncovered a way to crack the code. The study focuses on graph neural networks, GNNs, a type of AI that analyzes relationships in data, like social networks or molecular structures. These models are powerful but notoriously hard to secure. The paper introduces a new attack called CCMIA, Cross-Client Membership Inference Attack, which can determine which user contributed a specific data point to a federated system. So how does CCMIA work? Imagine multiple hospitals training a shared AI to diagnose diseases. Each hospital keeps its patient data private, but a malicious actor could use CCMIA to guess which hospital's data was used in the model. They do this by analyzing subtle clues in the AI's behavior, like how the model updates its predictions or how data points cluster together. The researchers tested this attack on real-world graph datasets, like social networks and molecular structures. The results were alarming. Their method identified data ownership with up to 72% accuracy, far surpassing previous techniques. Even more concerning, the attack didn't need direct data access. It simply eavesdropped on gradients, the AI's internal updates during training that clients send to the central server. What makes this attack so dangerous? Unlike traditional privacy threats, which only check if data was used, CCMIA links specific data points to the user who created them. This isn't just about guessing, it's about exposing identities in a system designed to hide them. But here's the good news. This research isn't just about the problem. It's a wake-up call for better security. The authors show that current GNN designs are vulnerable and highlight the need for new strategies to protect user privacy in federated systems. So what does this mean for you? As AI becomes more integrated into our lives, understanding these risks is crucial. It's a reminder that privacy isn't just about hiding data. It's about protecting the relationships and structures that make that data meaningful. The next time you use an app that claims to keep your data private, remember, the real challenge isn't just securing raw information. It's securing the patterns that emerge when AI learns from it. And as this research shows, even the most advanced systems have blind spots. Ever wonder how your data stays private when you use apps that learn from millions of users? Well, here's a tricky twist. Even when data is spread across different devices or servers, what's called federated learning, hackers might still figure out if your data was used to train an AI. Today, we're diving into a study that shows how cross-client membership inference attacks can expose this secret. Let's break it down. Federated learning lets multiple parties, like different hospitals or phone users, train a shared AI model without sharing their raw data. But this research reveals a big problem. Even if data is split, attackers can guess if a specific person's data was part of the training. How? By analyzing the structure of the data networks these models work with. Take the Cora dataset, for example, a network of academic papers. Each client, like a university, has its own slice of this network. But the way classes, like research topics, are distributed varies wildly. One client might have 80% of its data in one category, while another has a more balanced mix. These imbalances are a red flag for attackers. The study introduces a method called CCMIA, Cross-Client Membership Inference Attack. Here's how it works. Imagine two networks, one is the real data, and the other is a fake shadow network built by the attacker. By comparing structural features like how many connections each node has degree, or how tightly connected their neighbors are clustering coefficient, the attack can spot patterns. If the real and shadow networks match closely, the attacker guesses the data was used. To make this comparison fair, the researchers use a math tool called KL divergence, which measures how different two probability distributions are. They even tweak the math to ignore tiny, irrelevant differences, like ignoring a few dropped stitches in a sweater when comparing two knitted patterns. The results? CCMIA outperforms other attacks, especially on datasets like PubMed medical papers and DBLP academic publications. For example, in one test, CCMIA correctly identified if data was used 83% of the time, way better than other methods. And when trying to figure out which client a data point came from, CCMIA was often the most accurate. But why does this matter? If attackers can reverse engineer who contributed data, they could expose sensitive information, like a patient's medical history or a user's social connections. This isn't just a theoretical risk. It's a wake-up call for developers to build more robust privacy safeguards in federated systems. As AI continues to evolve, so must our understanding of its risks. This research isn't just about flaws, it's about pushing the field to innovate. The next time you hear about AI privacy, remember, the real challenge isn't just keeping data secret. It's keeping the patterns that make it valuable from falling into the wrong hands.